AD, Cartesian plane. Now, this may sound a little different to you. You may not have ever heard the term before. A Cartesian plane is the regular XY axes that you've seen for plotting points, plotting lines, or whatever the case may be. So, the fancy name for it is Cartesian plane. Sometimes it's referred to as rectangular coordinates. Sometimes it's referred to as a coordinate plane. Okay, but basically, it's just this. That's a Cartesian plane, rectangular coordinates, coordinate plane. It has an x-axis, so these arrows that are done here, which for some reason that arrow, I drew it the wrong direction. Okay, but these are called axes. You have the x-axis, or the horizontal axis, and the y-axis, or the vertical axis. When we plot things on a Cartesian plane, we use ordered pairs. Ordered pairs are set up as x, y. We have an x coordinate and a y coordinate, and where those two meet is that point, xy. So we would come over x and go up y to get to that point. Now, if I'm going to do that, then I should probably add some indices, hash marks and indices, to our Cartesian plane here. So I'm just going to add some marks, some hash marks on the axes. Okay, so I have some hash marks, and then I'm going to number them. Now, depending on what numbers you're trying to plot, you may number them differently, but the key thing is when you number the axes on a Cartesian plane, one, they should be numbered so that you can plot all the things that you need to, that they'll fit on there, and hopefully that they'll fill as much space as possible on there. Two, your indices, or the numbers that indicate where you are on the x and y axes, should be consistent on a single axis. So you either want to count by ones, count by twos, count by threes, count by fives, count by tens, but you want to be consistent. You don't want to go 1, 3, 7, 8, count by a certain amount. So you should have consistent indices. I'm just going to go 2, 4, 2, 4, 6, negative 2, negative 4, negative 6, negative 2, negative 4. Now, if you look at this, you'll notice that the x-axis is really just like our number lines that we dealt with in the past, right? That's your number line, x. The y-axis is just a number line too. As we go further up on the y-axis, we become more positive. As we go further down on the y-axis, become more negative. So what that does is that means that any positive x values will be on the right side of the axis, and any negative values will be on the left side for the x-axis. Any positive values will be on the upper part of the y-axis, and any negative values will be on the bottom part. It also means that if we're looking at these ordered pairs of x, y, that this Cartesian plane, any points that are positive, where x is positive and y is positive, will be in this upper corner. We call these four sections quadrants. Quad, meaning four. So there are four sections, we call them quadrants. The quadrants start here, and we call this the first quadrant, and that's the Roman numeral 1, the capital I, Roman numeral 1. The first quadrant. In the first quadrant, both x and y are positive. We then go counterclockwise numbering the quadrants. That's the second quadrant, 2, again using Roman numerals. The third quadrant, 3, using Roman numerals. And the fourth quadrant, 4, using Roman numerals. Anytime you indicate a quadrant, you should use Roman numerals as opposed to Arabic numerals. Instead of just a 1, 2, 3, and 4, IV. In Roman numerals, an I represents a 1, a V represents a 5, and putting a 1 before that 5 says take 1 away from 5, giving you 4. So you have 1, 2, 3, 4. You may have seen clocks that have this type of numbering on it. And if you look carefully at movies when you watch them, they tend to put the year in Roman numerals at some point in it. In the credits or at the beginning of it, they will show that. So in the first quadrant, X is positive and Y is positive. In the second quadrant, X is negative and Y is positive. In the third quadrant, X is negative and Y is negative. And in the fourth quadrant, X is positive and Y is negative. So knowing these relationships allows us to easily plot points on our Cartesian plane. So let's plot some points. I'm going to use this same XY axis that I've already put up here. It just saves me a little bit of hassle of redrawing it. And we're going to plot the points negative 2, 4, 5, negative 1, 2, 3. So we're going to plot these 3 points, and I'm even going to label them and call this point A, point B, and point C. Now, points don't necessarily have to be labeled with a letter, but that's going to make it easier where I can look at this and say, okay, negative 2, 4. I come on the x-axis, remember, that's x, y. So I come on the negative axis, the x-axis, to negative 2, and then y is equal to 4, so I go up to 4, and I label that as point A. If I didn't have letters that I gave them for labeling, then you could say that you could just put next to that point negative 2, 4. But you can see how that kind of gets bulky and a little laborsome, so we're going to get rid of that. So we have A. B is at 5, negative 1. That's 5 in the x, negative 1 in the y. So there's B. And then C is 2, 3. So x is equal to 2, y is equal to 3. And we have C. So the way I like to plot them is I go in the x direction to wherever it is, and then I go up to the appropriate y. Some people like to do this, where they'll say, okay, 2, 3, they'll come out to x equal to 2, and y equal to 3, and then they look for where that connects there. So they'll come out, and look for that intersection. The only problem I find when people do that is sometimes they'll they end up plotting the 2 and plotting the 3, and they give me 2 points to indicate that one, and that's not really plotting it correctly. But that's how we plot points. Pretty straightforward. We just have to remember that our ordered pairs are always x, y. The horizontal axis is x, the vertical axis is y. If you get confused on that, just remember x comes before y in the alphabet, and the horizontal axis is your number line that you've always dealt with, and then this y-axis is a second number line, so it's going to come after this one. So this first value is going to go on the number line, the x-axis. The second value is going to go on the y-axis to come and get our point. Well, one last thing I'm going to do with this is, what if we have a table of values and we want to plot this table and put it on the graph? So I'm just going to have some random values. So I'm going to put x and y. Now realize that I could call these anything. This first column, the x value, is usually referred to as an independent variable. Independent. If something's independent, it doesn't rely on anything else. So the independent variable, that's like the starting variable. And then y, the second one, is referred to as the dependent variable, meaning that it does rely on something else. So give me an x value, and some y is going to be the result of that x value. So we have our independent variable and our dependent variable. No matter what they're called, the independent variable goes on the x-axis, and the dependent variable goes on the y-axis. And then we get our points. So if we have 3, -2, 4, 1, 5, 3, -2, -4, and -1, 5. Now we have some points that we can plot here, and realize this is no different than me, say, giving you the point 3, -2, 4, 1, 5, 3, -2, -4, -1, 5. So it's really just an ordered pair, 3, -2. Right? So there's no difference, it's just instead of writing them as ordered pairs, we just put them in a table. So now if we want to plot these, we just go through and plot them. So we have 3, -2, 3, -2. We have 4, 1, 4, +1. 5, 3, 5, +3. -2, -4, -2, -4, and -1, 5, -1, 5. And we have now plotted those points. And there are many reasons that we may perform a plot like this and use it to show things. Many times something like this would be considered a scatter plot, which means we're just given some x and y values that are related to each other, we just plot them in there. There is no series or sequence to it, meaning that this 3 doesn't necessarily lead into that 4 into the 5 to the -2, so we don't connect the dots, we're just plotting them on there and we can see what happens. Many times with this we'd be looking to see if there's a trend, and I kind of see a trend. Ignoring that one, I see a trend here that seems like as x increases, y increases. But then we have that one there, and when you get that in there, it kind of mixes things up a bit. So maybe there's no trend, it could be completely random. But that's how we deal with the Cartesian plane and plotting ordered pairs.